Hey, welcome to PyHacks. This is part of Hutsons-Hacks tutorials. Today we're going to be focusing on Python, specifically Python lists. So what I'm going to do first of all is I'm going to open up my Anaconda Navigator. I'm going to select my environment, my customized environment that I've created, and I'm going to launch Spider. Okay, I'll just get rid of the code. So Spider is similar to Jupyter Notebooks, but it's more of a text editor, which I prefer. So today we're going to be covering everything to do with lists. So we're going to get on with actually creating lists. We're going to go through list comprehensions, list operations, everything you can do with lists. So we'll just need NumPy for this one. So I'm going to give it an alias MP, and then I'm going to create my first list. So to create a list in Python, we're going to assign it a variable name to store it in memory. And this is going to focus on programming languages that I'm experienced in or that I enjoy. Your list, you can make up whatever you want. Say Python. So in the square brackets, this is how you create a list in Python, in memory, C#, SQL, JavaScript. Okay. What I like about Spider is if you press F9, you can evaluate it as it goes. So you can see that my programming languages variable has been created in here, line by line, and now I've got it in my Explorer window as well. So it's a size 5 and I've got these list items in there. To print this out to the console, you just put print programming languages. Okay, so you can see that now my cell's been run. My programming languages has been created as a list in memory. To get the length of the list, I'm going to use print len programming languages. You can see it returns the length of 5. And then I'm going to create another list. Let's create an additional list. Add an additional list. Okay. I'm going to call this code experience. I'm going to create a list of 5 by 5 years, 9 years for R, 5 years for Python, 9 years for R, 6 years for C#, about 15 years for SQL, and 3 years for JavaScript. Or you could just put a missing value. So let's keep it a NumPy none. No, we'll put 6 years actually. We're not doing any missing value imputation today. Okay. So that's created another list. So if I print that again, I'm going to run the whole script this time. See that my new list coding experience has now been created in memory, same size as programming languages, and it's also been output to my console here. Okay. So what we can also do is check the list's type. So internally in Python, how it's stored. So to do that here, I'm going to put print type. Type's a special command. I'm going to pass in code experience. And we're going to run that line in F-line. And you can see that here it's returned a class of a list because we're creating a list data structure in Python. There are 4 main data structures in Python. This is the first of 4 tutorials. I'm going to go through list, tuples or tuples, sets and dictionaries. So the difference between a list and a tuple, which you normally kind of compare, lists are mutable, so you can make changes to lists, and they can be ordered and changeable. And it also allows duplicate entries, so duplicate members to be contained in the list. That behavior is also the same in tuples. It allows duplicate members, but once it's been created, it's immutable. You can't make changes to a tuple. And there's reasons for that, like not wanting to write over things. So in CV2, which is a kind of Python computer vision library. Things like the X and Y coordinates of a picture you wouldn't want to change or be able to change. So they have fixed lengths and they return the fixed lengths as well. Okay, so far we've created two lists. We've printed the length of the list, and we've also checked the type is a list item. Okay. So what we're going to do now, we're going to use a list constructor. So creating a list another way, creating a list using the list function. So I'm going to specify roles that I've had in my career. I'm going to use the list operator. And here, because I'm passing multiple tuple elements in, I'm going to put senior data scientist, say head of analytics, Windows Form developer. That's where I used C#. Been an analyst for a long time and did some web development back in the day. So this is another way to create a list. See, we've got these square brackets here. You can also just use the special command list. So if I run that 9 and press F9, you can see I've got another list called roles that's been created. Okay, so that's the creation of lists. So that's how you create lists. Next, we're going to look at how we access items from lists. Okay. So let's say we want to make a copy of our list. So we're going to use the original programming languages. We're going to create a variable there. I'm going to do the prog languages to create a copy of it. .copy, which is a special method to actually copy the list. So now we've got this original programming language just to make a backup because we're going to make some changes to that. So let's do some negative indexing then on the programming languages. So we're going to print programming languages and we're going to go get as the last element. So -1 is the last element of the list. So it'll bring back the last programming language that's been entered, which is JavaScript. So that's a raw index of how you get the last element. If you want to get a range of indexes, okay, I'm going to create another variable called data science languages and we'll create a subset. Let's call it subset. We can use prog languages. Okay, this creates a subset from 0 index of my programming languages. So it's going to get the first 2 items, so 0 to 2, not including 2. So in list indexing, it goes up to 2 but doesn't include 2. So 0 and 1, so it's like the range that it's going to include. So you can see this DS languages subset is brought back Python and R. It's not brought back Python, R and C because it goes up to the second index here. So it's only going to return these before that. So from 0 to 2, cuts off here and returns these 2 variables here. So that's why you've got your Python, your DS languages subset that's been created as a list of 2, as opposed to the original list of 5. Okay. Another way to have done this would have been to do it this way. So as you can see, I'm using hashes. That's how you make comments in Python. So far we've created variables, we've created lists, we've made comments against that. So indexing at a certain position then, so I could go print programming languages again. And this time I could say the special command, get me everything up to 3. So I've not passed in this 0 here. So see what this does. So actually now I've got all the indexes up to index 2. Remember, Python starts at 0 indexing scheme. So 0, 1, 2, but not including the third index, which would be SQL. So it's always up to, not including. That's something you need to remember. We could flip that round and we could go print programming languages. So get me everything. So that means this special command here without anything before it, instead of specifying 0. Everything up to item index 3, but not including index 3. Here, we're going to say everything up to index 3, and this will include, so after index 3, which includes index 3. Okay. So, sorry, it's just 2 to include index 3. So now you get C#, SQL, and JavaScript as well. So that's creating list items and then accessing those list items. What I'm going to do now is I'm going to show you how you change list items. So we're going to just create another variable of programming languages. I'll just keep creating variables so we don't override. So I'm going to call that prog. So we've got this list again, prog. And we're going to say, actually, we want to change the 0th index to another value. So we can go prog, grab the 0 index, and then all you do to set the new value is go equal to, we're going to set it to a string because it's a set of strings. One thing I should note about Python, you can use mixed types in lists. So you can have a string, a boolean, a float, a numeric, an integer, that kind of thing. I'm going to put Python rocks. So that will change the 0th index. And if now I print prog, I'm just going to run those lines. You've got, as you can see here, and you'll see it on one of these as well, on the prog list item, you've got your first index Python rocks, and it also prints out to the console because it uses the print command here, Python rocks, so it's successfully changed that list item. Again, you can do the same for changing a range of items. So say if I wanted to change prog 1 to 2, and we wanted to change it to a list of multiple items because there's multiple values, R programming and C, I'm just going to change how it's spelled, C#, and then I print out. You can see this is making changes to the original variable. That's why you have to make copies. Otherwise it changes the original data frame, which is a behavior of Python by default. So you can see now we did the change here, Python rocks in the first line on the 0th index. Now we've done it from index 1 to 2 by using index slicing. You've got R programming and C# there. Okay. And the same could be done. You could have just done that without 1 to do a range, to do everything up to 2. Is another way of doing that. So we've changed list items, we've created indexes, and we've also gone through how we can select items. Now I'm going to show you how you append items to a list. So again, as is good practice for this demonstration, I'm going to create a copy of my coding experience variable, codeexp. And I'm going to copy that, which is a method to copy that because it does something. Methods, there's two different types. There's methods and attributes in Python. So an attribute is more of a descriptive. A method actually does something to that list, data frame, value, variable, whatever you're talking about in whatever context. Here we're talking about lists. Let's append to a list. So we'll find the length of that list. We know that it's a 5, so we're going to append to item 6 another value. So we're going to use code, copy, and then we're going to use the append method. I'm going to append to item 6. So we've added a 6 look to code experience. So now this code, I meant to put code copy. This code list is now got another value because we've appended one onto the end. Okay, makes sense. Okay. And then what we could also do is insert between a list index at some point. Insert a list item. So here I'm going to have to use code. I'm going to use the insert method now. So it says which index as an integer do you want to insert it and what object type. So we're going to insert it at, we've got the code, so we've got an item at 6. So we're going to add an item between index 0 and 1. So I'm going to add it at the first position. So what this will do is the original item at 1 will get moved to the right, and this will get put in its place. So it retains the values, but just adds to it. So let's say we've got a coding experience of 10 years. And then if I print code, you can see now code has got this. So we've got the original code here, coding experience, 5, 9, 6, 15, and 6. Because we said we wanted to insert it into the first index, which is actually the second in Python, remember 0 indexing. The first index, I'm going to put the value of 10. That's exactly what it does. And as you can see at the end, we've also appended this 6. So now it's a 7-sized list. So a list with 7 elements. Okay, you can also extend a list. I'll just finish this example and then I'm going to break this into a couple of components. So I'm going to extend this list. So we're going to use the programming languages now. Or did we make a, yeah, we made a copy. Let's use prog, the copy of it. And we're going to then say extend this. And we've got an item called roles. So it'll essentially extend the list and add roles to it. So if I print prog now, I'm going to run these 2 lines. This is why I like Spider, and press F9. You can run it line by line, which some code editors don't do. Obviously Jupyter Notebooks will do that. This is kind of a text editor alongside the Anaconda framework that allows you to do it in a more scripting fashion than perhaps you've seen before. So now you can see that actually we've got these programming languages, and then we've got the roles appended on the end. So language and experience at the same time in one list. You'd probably want that as a data frame alongside each other, but this is just an example of how you'd extend that list. Last couple of things we're going to look at how you remove items from a list. We're going to do that by name, by index. Okay. So I'm going to say from my programming languages, I've not used JavaScript in a while. So I'm going to create a copy of this programming languages and I'm going to remove the item JavaScript. Let's call it prog reduced or something like that. I'm going to prog copy it. Again, make a copy of the original so it doesn't make changes. Oops. And then from here, I'm going to do prog reduced remove. I'm going to remove the actual value. So we're going to say, let's remove JavaScript. I'm going to print out prog reduced, just so we can see it in the console. We'll also see it in the variable editor in Spider, but you won't see it in things like VS Code unless you really search for it after you've executed the script. So prog reduced, you can now see we've removed JavaScript. And because we extended that list, we've also made a copy of the extended list, prog extend roles. So we've got the roles added on at the end as well. So that's how you remove an item there. And if I wanted to remove an item by index, so let's remove an item by index. We're going to then go, I don't know, prog reduced. I'm going to use the pop method. I'm going to say let's pop the first index. So that'll remove prog. Actually, let's remove Python. Yeah, let's remove the 0th index and print prog reduce. That'll get rid of Python rocks that we amended earlier. Okay, F9. You can see now we've got rid of, so prog reduced will now have a list of 9. And we've got rid of Python rocks, so now it's got all programming in C#. If you don't specify an index item, it'll remove the last item in the list. So if I ran this again and pressed F9 on that, and then again, it's removed the last item. So that will be the Windows form developer. Not Windows form developer, sorry. What was the roles? Whatever's in the roles anyway, it'll be the last item of roles. There's another way to do that. So instead of using pop, we can also use the del command. So deleting lists or list items. So you can go del prog reduced. This is why I made a copy, because I'm going to delete the whole list in a minute. And then say, because our program is now gone up to the 0th index again, let's say we want to remove C#, which is at the first index. As you can see, 0, 1, C#. So I'm going to do that, and then I'm going to also print it out to console again. You don't have to do this in Jupyter. Using the print command, it just executes it for you, but in script editors, you have to get used to using print. So F9, and that's now deleted that element, that entry. So you can see C# was there before, now it's disappeared. If I wanted to delete this list completely, I'd use this command. So I'd use del prog reduced, and then I'm going to operate on that. I'm going to press F9. As you can see now from my variable editor window, the list is disappeared, so it's no longer available to be referenced in memory. Another way you can do it, say you don't want to delete it from memory, but you want to clear all items in the list. So just flush it, purge it. So say I've got this prog, which is based off the original prog, which has also got roles appended to it. So I'm now going to clear that. So I'm going to use the prog dot clear method. And I'm going to pass nothing to that, and then I'm going to print prog afterwards, and you'll see what happens. So we should get an empty list, which will look like this. Just empty square brackets, which means you've got nothing in that list. So F9. Yep. So now you can see, you can verify this in a couple of ways. I verified it in my console. I've got nothing there now. It's returned nothing. And also in the window here, I've got a list item and nothing. You could also verify that that's been achieved by the size, so you can put an if condition together. I'll show you how to work if conditions at another time, so conditional statements. Here we're just working with the data structures. Okay, that concludes this part of the tutorial. In the next step, we're going to look at looping through lists and something called list comprehension, which is a really cool Python feature. So I hope you find that interesting, guys. In the next tutorial, we'll look at looping lists and list comprehension. Catch you on the other side.